Good morning guys, welcome back to my channel. So today's lead code question is problem number 3372. Maximize the number of target nodes after connecting trees 1. So let's read the problem first. So in this problem there exist two undirected trees with n and m nodes with distinct labels in range 0 to n minus 1 and 0 to m minus 1 respectively, where n and m are number of nodes in both the trees. So we have given two integer arrays and 2D integer arrays, edges 1 and edges 2, that tells us about the edges. And uh, there is an edge between AI and BI if AI and BI, this type of edges are given, and edges 2I, which tells us about the edges in the second tree. So node U is the target to node V if the number of edges on the path from U to V is less than or equal to K. Note that a node is always target to itself, and return an array of n integers answer, where answer of I is the maximum possible number of nodes target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. So let's check the example so we will understand better. So we have given these two trees. A tree is, everyone knows, is a graph having the number of edges less than the number of node, one less than the number of nodes. So in this question we have to find out the maximum possible coverage a node can do. For example, let's try to check in tree number 1. So if we add node 0 and the value of k is 2, that means that we can traverse only uh, up to depth 2. So if we traverse from here, the thing is, one thing is given in the question, that uh, one node can traverse itself also, and the tree is undirected, that we can go to 0 to 1 and 1 to 0 also. So if we check tree number 1, so the number of nodes that 0 node can traverse is 1, 2, 3, 4 and 5, and the same thing we have to do for every node. And the main twist is that we can connect a edge between tree 1 and tree 2, and we can connect between any two nodes. For example, if we add node number 0, we have to return an array that tells us about the maximum coverage by every node. For example, answer of 0 means we have an array answer, so the answer of 0, that means at index 0 uh, we have to return the maximum coverage by node number 0. So we can connect this node 0 to any of the node in tree 2, and then we have to compute the maximum coverage, and we can connect this 0 node to any node in tree number 2. So for example, we can connect 0 to 0, then the maximum coverage is 1, 2, 3, 4, 5, 6, 7, 8 and 9. The maximum coverage is 9 and the answer is 9 itself, but we have to find uh, which node in tree 2 will give maximum coverage. So according to a brute force approach, we can check this node to every node of the tree 2, and we use BFS to find the maximum coverage. But this solution has a problem of time complexity, because we have to check for every node in tree 1 also, and we have to check for every node, we have to check in tree 2 for every node, and it will be greater than the 10, it will be the order of 10 to the power 9, which will not be done in 1 second only. So the approach is that we have to check for example, if we add tree 1 tree to tree 2 edge, so we can subtract 1 from k, and we check only up to depth 2 in tree number 2. Depth I'm sorry guys, we have to check only up to k minus 1th depth in tree 2, and we have to check for every node. The maximum coverage we store in an integer value, and for every node we have to check the maximum coverage and add that maximum coverage to the maximum coverage of tree 2 with k minus 1 node, k minus 1 depth, and in this tree 1 k depth only. So this can be done in very simple way. So I have stored integer m and integer n, the number of nodes in tree 1 and the number of nodes in tree 2, and I have created an adjacency list, and this is the result we have to return. We have to return the result of every node in tree 1, so that's why its size is m only. So I have created the adjacency list for this, and now check I have to check for every node in tree 2 and up to k minus 1th depth only, because one edge is already used when we go from tree 1 to tree 2, and at last we return the best coverage it can do. For example, in this case the best coverage is done by 0, that is 1 2 3 4 and 4 only, because we have a k is equal to 2 and we have to do only up to k minus 1, that is 1th depth only. So it has maximum coverage 4, and in this we have to do up to k is equal to 2 depth, and it is maximum coverage is 1 2 3 4 5. So the sum is 5 plus 4 is equal to 9. So the same thing is done in tree 1 up to k depth only, and we add the value to the best optimal coverage by tree 2, and at last we return the answer, and it is the simple BFS. And in this BFS we have to return the maximum coverage, so little bit changes are done in it, and for up to k depth only we have to decrease the value of k at every iteration and check whether the k is greater than equal to 0 or not. And this is the simple solution. So I will run it. So it is accepted. It is accepted guys, and the time complexity is v plus e for BFS, and we have to do it for every node in tree 2. Then we have to multiply it with n, and n into v plus e, and we have to do BFS in tree 1 for every node also. So it is of m square. So the total complexity is m square plus v plus e into n. So it is in the range, that is it is less than 10 to the power 9, so it can be done in 1 second. So that's all guys. So to watch the solution for every LeetCode question daily, subscribe to my channel and like and share the video also. Thank you guys.